is currently an SDI specialist at ISRIC. And he's been very involved also in FOSS4G projects like GeoNetwork and PyGeo API. So without further ado, I give you the room. I don't know who is starting.
Maybe I can start.
Okay.
Let's see. I'm wondering if I'll share the screen. So maybe Paul, I'll drive, and then you can just cue me. Is that okay? Okay. I see you're on mute, but I see that you agree. So let's go with
yes.
that. Okay. Whoops. Sorry about that.
Ah, I'm muted. I didn't know that. Hello.
Hi. Sorry, I don't know if you were trying to say something.
Yeah, I was. Yeah, fine. Go ahead, Tom.
Cool. So, okay. So maybe I'll start off with a couple of notes. I guess this presentation is on how QGIS and is increasingly supporting the OGC API efforts, and we'll talk a little bit about how they work together. I'll provide a small update on the OGC API efforts, and then Paul will get into some of the details around QGIS, and we're happy to answer any questions or comments. So OGC API, hopefully you all have heard of what OGC API is. So going back in time a bit, we've started from in the mid to late 90s around doing web services with a lot of XML and basically remote procedure call over the web, and we moved on from there to sort of web 2.0 type things. There were some realities associated with having those OGC with specifications designed in that certain way in terms of overloading the HTTP specification, as well as some difficulties in having things crawlable or searchable on mass market search engines and so on. So, excuse me, in 2017, the W3C came up with the spatial data on the web best practice, and a lot of efforts started to sort of culminate around the concepts of REST as well as JSON and Open API. OGC had an API white paper in 2017, if I'm not mistaken, which basically called for a lot of created the opportunity to create these new OGC API standards, which focused on JSON and HTML as first class and making things mass market friendly and web developer friendly. A web developer should not have to download a 400-page document to implement the specification, whether it's a server or client or what have you. Mind you, I don't think anybody should have to download a 400-page document, but here we are. You can see a number of the specifications down below, whether they're maps, styles, coverages, features, and so on. Most of them are successors to the first generation of OGC API standards. These standards are developed interactively. So these standards are developed now on GitHub. If you go to github.com/opengeospatial, you'll see a number of the standards there. If you go to ogcapi.org, you'll find all the information on all the APIs and all their specification documents fully available there in HTML. There's Gitter chats so that you can easily interact with the community around the specification development and questions around compliance and conformance and testing for that matter. As mentioned in the previous presentation by Clemens, Peter, and myself, there's really a building block model to all of these specifications that will allow you to sort of plug and play and put those Lego bricks together to be able to come up with something that meets your needs. With that, I'm going to turn it over to Paul.
Thank you, Tom. So I use it. Sorry. So where to start? So, OGC API features and QGIS. a lot of people contributed to QGIS over time. I'm not in a position here to mention everybody that contributed, but hopefully I give everybody that contributed enough credits. Here they are. But I want to dive in quickly, since we only have 15 minutes, to see some functionality that is available these days. So starting with OGC API Features, since it was also the first one that kind of got adopted within the OGC, or started the movement. This was implemented by Yvan Rouault and funded by Planet, and it was implemented as an extension to the existing WFS provider. So I think this landed in somewhere 314, 316, I don't know. You will find this functionality under the add WFS layer, and then instead of putting there the WFS capabilities URL, you put the OGC API Features URL, and from then on it kind of works in the same way, that it fetches the layers from the service, and you select the layer, and you add it to the map. There's some special parameters that you can add here, for example, the pagination size. So in that sense, we have the same challenges as WFS, that if you have a very big page size, that the service may actually load quite slow. If you make a smaller page size, it will be faster, but you will only see a partial result. This is always something to keep in mind. Yeah, so also good to know here is that it uses behind the scene the same architecture as WFS. It means that QGIS caches the features in a local cache. So if you zoom in and zoom out outside the area, it will still have the previous features in its cache. So it doesn't need to go back to the server to fetch them again. Next slide, Tom. So from Yvan, we discussed a bit before this meeting. Some learning points from his side is that the fact that the items in a collection most of the times are untyped. So in theory, you could add them, add the definition of the item to the OpenAPI document, but the specification doesn't necessarily need you to do so. So if you have there an item, say a tree, if it has a property branches and size, that could be specified in the OpenAPI document, but it's not always required. It means that a client like QGIS has to get the first page of results to see what is actually returned and which properties are available on the object. It's a bit awkward for a client, and especially people that are used to build clients against OpenAPI specifications will be a bit surprised about this outcome. On the other hand, for the server implementers, this is easy, because they don't need to go into each object to see what properties it has and advertise it in OpenAPI document. Another point that we came up a discussion is that if you have hierarchical data, like for example, I have a soil profile. In the soil profile is a horizon, and in the horizon has a certain clay percentage and a certain magnesium value. To query the magnesium concentration over the 12 micrograms for the second horizon in profiles within a B-box, you need quite a dedicated filter expression capability, and this is currently not yet fully crystallized how that will work out. But it's something that we maybe we have some time this week to discuss that topic. Next one, Tom. OGC API records. I give the floor to you, Tom, for this one. You're muted.
Okay, great. Thank you, Paul. So for OGC API records, as Paul mentioned, QGIS is a long-standing project with a number of contributors and a long time solid support of the OGC standards. So we can see WMS, WFS, WCS, and so on. Paul just talked about OGC API features. Now let's talk about search. So in QGIS, which Paul and I are presenting on tomorrow, if anybody's interested in seeing that presentation, I won't go into too many details here, but in QGIS, there's been a long-standing catalog client called Metasearch, which has always worked with the OGC catalog service for the web specification. Well, in the last year, alongside of working in the OGC standards working group, we also implemented extended support in the Metasearch plugin, which is a core part of QGIS. So when you download QGIS, you will have the Metasearch plugin installed by default. Where it's almost merged, but as you can see in the lower left part of the screen, but we implemented OGC API record support in Metasearch. And Metasearch internally uses the OWSLib Python client, OWS client library. So that client library itself has been extended to support OGC API features, records, and coverages. That's the current support, and we're extending it as time goes on and more OGC API specifications are ratified. But we do have a pull request in with some working functionality against OGC API records. So there you can see a screenshot there. That's hitting that could hit an OGC API records endpoint in the same way that it would a CSW endpoint. So we've extended the client to be able to do that. So when that's merged, you'll be able to say, okay, add my OGC API records client. You do have to specify that it's an API records endpoint or a service as opposed to a CSW service. And then after that, all of the functionality is abstracted away. So you don't really know whether you're working with a CSW or an OGC API records client, and that's the goal of the beauty and the value of the Metasearch plugin. So in theory, we're able to add any type of search service, but here we're concentrating on QGIS, on OGC API records for that matter. And in that work, we actually did some digging in Metasearch and abstracted the search capability to make it very, very easy to add more APIs over time if we need them, or profiles of OGC API records for that matter. So like I mentioned, it's currently a pull request. We just have some final issues to deal with regards to packaging, and we hope to have that merged very soon, maybe even this week. There's a code sprint on Saturday, so let's see what can be done with regards to that. Whoops. Some issues or some discussion points that came up with OGC API records. Link types. I mean, this has always been an issue in catalogs and search APIs in discovering actionable links. So how do I know that a link is a WMS link or a WCS link or a WFS link? Well, we've always had that issue, and we have a way of working with that in QGIS, which also requires some cooperation from the metadata providers. But now we have a new specification with not only having the requirement to articulate the link types of the first generation OGC web services, but now we introduce link types of the new OGC API standards. And the link types in the OGC API records case is going to be a lot easier for Metasearch because we have the ability to crawl down a certain level of an OGC API record endpoint, so we can get to just that collection because of the hierarchical and the RESTful approach of the way the standards are designed. So you won't have to open Metasearch, find the data set, add the WMS, and go back and do a get capabilities again and do that round trip and find the layer. Now you will be able to connect to the OGC API records endpoint, find the matching record, and whatever the link type underneath is, which when it's an OGC API link, you'll be able to load that directly in QGIS. So I think that's going to be a very valuable feature as more and more of these things get put online and server data providers make their discovery metadata available through OGC API records and the new link types. So there is change management involved, but that's OGC Web Services and OGC API change management thing that I think will be here for a while. And this is what that some of what that change management looks like here in OGC API records and what that means in QGIS. Other issues with regards to QGIS. There are other OGC APIs as we've mentioned. We're not aware of any current initiatives at this point in time that implement the other APIs, but I would imagine over time that we'll start to see updates on clients for maps, tiles, coverages, and processes as those specifications mature and they're formalized by OGC, and clients want to have that functionality implemented. The OGC does have an API roadmap, which will be valuable I think is valuable for folks to look at if they want to see what the timelines of the specifications are, and that'll give the QGIS community a better idea of when's a good time to dive into the standard and implement it. So I think this is a great advancement in the OGC API standards, and QGIS is a very powerful GIS client. And we've demonstrated that we're able to implement these standards with a relatively low barrier workflow. Paul?
So yeah, let me take that one. So while discussing with Ivan, he of course he introduced the aspect that GDAL supports the full OGC API, actually a bit more than QGIS itself by now. So there's support for maps and tiles, but it's actually possible to add those to QGIS also via this MOAW. I don't know. You say MOAW file? I don't know. So it's kind of a processing file where you say, okay, load this data via GDAL. So that's already an option in QGIS. So if you really want to have your OGC API maps in QGIS, you can do it via such a file that's described on that endpoint. Next one. Yeah, so then dive a bit into QGIS Server. Of course, QGIS is mainly a desktop application, but there has been some initiatives to have also QGIS as a server. So you run it as a Docker instance and request it as a WMS or WFS. And within that, next one, Tom. Within that area, there was also an initiative to add OGC API features to the QGIS server. And it works actually out of the box. The only thing you need to be aware of is that once you, before you upload your QGIS project to the QGIS server, you have to tick a box in the server properties of the layer, saying that it should be exposed as a WFS layer. It will then automatically be advertised also as an OGC API features layer. So that's really useful. As far as I know, no support for maps and tiles also on that side yet. But yeah, I hope that that work starts soon. Next one. Yeah, so that's about it. Do you have a QGIS there, Tom, or shall I? Maybe Joanna, maybe you can add my screen to the.
That's a good idea.
But it's also, maybe you can already prepare some answers to some of the questions, Tom, because we enter the discussion phase of this presentation. So I have here a QGIS instance with focused on the Netherlands with some of the provinces, and those provinces are actually coming from the OGC API features. So if I add a layer of type, in this case I have to go add WFS layer. That's the one that includes the OGC API features. Here is the first you have to set up a server connection. If you edit that, you will notice that you just put here the endpoint of the in this case it's a PyGeo API running on a sandbox environment, and here you have those options like putting the page size, and you can detect here and says, oh, it's an OGC API features, and then from that it will fetch from the collections page all the collections that are available in this service, and you can then add that to the map. So it works exactly like a WFS service. And I wanted to add this aspect also related to the OGC API records, is that this implementation also helps us at the server side to develop our server, because it gives such an easy client experience that we always use QGIS for testing our server implementation. And that's also a benefit, because we make sure that it works on QGIS first before any other client. Unfortunately, I cannot show the OGC API records on my Metasearch because I had a problem with the OWSLib. Sorry, Tom.
That's okay. I mean, we are also running out of time.
That's
Paul,
so yeah. So we better go into the questions.
Yeah, thank you very much. Okay, so we have two questions here. So the first one is, speaking of caching, caching is also needed for WMTS XYZ raster tiles in QGIS. QGIS is now responsible for the largest data load of the free map raster tiles, according to the OSM org maintainers. Hope that becomes better with OGC API? It's a question.
Yes, I don't know the internals of how this is managed in QGIS, but I know that I am one of those users that add open layers OpenStreetMap almost every day. So I can imagine that it's very popular. I mean, having the white screen with a simple shapefile on top just looks bad. You always want a background, and OpenStreetMap is also my favorite one. But yeah, I think. Providing these background servers, background tile servers, is really a point of attention. Like a GeoNetwork, GeoServer, open layers. In all their examples, they're using the OpenStreetMap tiles, which is a community initiative also. So we should be careful. I hope at some point OSGeo board, for example, may set up a tile server that we can use for this type of demos. And it doesn't need to go up till level skill 18 or 20. If it for this type of demos, skills 12 is just fine. So that's my idea on that. I don't know. What do you think, Tom?
Yeah, no, I don't know very much about the internals, but yeah, I'm with you, Paul.
Okay. So the next question is, do you think we will need not only a QGIS OGC API extension, but maybe, thinking in the future, a different QGIS platform that support and display the requested information? Think on Sparkle queries. It will be possible to gather not only maps, geolocalized data, but also sounds, measurements, pictures, papers, videos, etc.
I think that's a good question. My initial reaction to that would be QGIS provides a strong mechanism for extensibility, so you can develop your own, for example, your own Python plugins. So you can, I could see an ecosystem of plugins being made to satisfy those work cases and those use cases. In fact, Metasearch itself is written in Python, not C++. So I can't see, I can see an ecosystem of these plugins being built just the same to deal with Sparkle and maybe some other things. I don't know, Paul. What do you think?
When I look at, for example, to the 3D world, in a 3D world view, you interact with what you see around you, and this is also a bit the paradigm of QGIS, that it's layer oriented, and it's really hard to make links from like we see here, the cities of the Netherlands, and then there's the OpenStreetMap in the back. But it's really hard to make an interaction between the two, and that's related to the QGIS and most of the GIS desktop clients. But in a 3D world, it's far more common to click to follow layers and see interactions between a traffic light and a street that it's connected to, and a sound that it makes. And when I see a thing like Sparkle, typically is also object oriented. You go through a network of objects, and I think QGIS by design is not really a tool fit for such spatial navigation. So that's a bit where I'm heading. On one hand, the layer paradigm brought us a lot, but now it hinders us to advance in a direction. And I think at some point we need new clients that engage with data in a more object-oriented way.
Okay, thank you very much, Paul and Tom. Let's give a virtual clap to the speakers. And before moving to our next presentation, so we're going to be talking about modular OGC API workflows for processing and visualization.